In 1961, a scientist almost accidentally destroyed the entire field of weather prediction. He didn't mean to. He just rounded a number. Instead of typing 0.506127, he typed 0.506, 3 decimal places. A difference so small, you'd never notice it on paper. The result? A completely different weather pattern. Storms appeared that weren't there before. Clear skies vanished. 2 weeks of simulated weather, unrecognizable from what the full number would have produced. That scientist was Edward Lorenz, a meteorologist at MIT. And what he discovered that day didn't just change weather science. It changed how we understand everything. Everything looked stable on paper, but inside, something was breaking. That's how Lorenz described his model before he noticed the error. On the surface, clean data, predictable outputs. Underneath a system so sensitive that a rounding error could unravel weeks of forecasted reality. He called it sensitive dependence on initial conditions. The world gave it a simpler name, the butterfly effect. The idea that a butterfly flapping its wings in Brazil could set off a tornado in Texas. Not metaphorically, mathematically. Small causes, enormous, unpredictable consequences. Now let's make this human, because this isn't just about weather. Think about one specific moment in your life, a small one, the kind you almost didn't notice at the time. Maybe you almost didn't go to that one gathering. Maybe you replied to a message you nearly ignored. Maybe you took a different route home one evening. Now trace forward from that moment, the people you met, the decisions those meetings led to, the version of yourself that exists right now, sitting here, watching this video. It's possible that small moments can have consequences, far greater than they appear at the time. We can't prove it mathematically, the way Lorenz proved it, for weather systems. Human life is far too complex to trace that cleanly. But the pattern feels familiar, because most people, when they look back, can identify a small moment that seemed insignificant and turned out to matter enormously. Here's the room going quiet. In the 1970s and 80s, mathematician James York at the University of Maryland, along with other researchers building on Lorenz's work, helped formalize what we now call chaos theory, the mathematical study of systems that are highly sensitive to initial conditions. What chaos theory revealed was deeply uncomfortable for science at the time. Even tiny measurement errors can grow so quickly that accurate long-term prediction becomes impossible for many chaotic systems. Not because we lack data, because the errors compound faster than our ability to correct them. The gap between what we know and what we need to know grows with every step forward in time. The universe doesn't hide things from us deliberately. The math just makes certainty disappear before we can reach it. And here's what that means on a human level, the part worth sitting with after this video ends. Small things compound, not because human life is a mathematical, chaotic system in the strict technical sense, but because consequences travel forward in time in ways we can almost never fully see. The argument you had that quietly changed how someone saw themselves. The sentence that stayed in someone's mind for years without you knowing. The habit you started or didn't start, whose effects are still arriving. None of these feel significant in the moment. The butterfly doesn't know it's causing a storm. It's just moving its wings because that's what it does. And that's the honest, uncomfortable part of all this. You are constantly setting things in motion whose full consequences you will never be able to trace. Lorenz spent his life studying a world that couldn't be fully predicted. He didn't find that disturbing. He found it honest. The atmosphere has a kind of memory. What happens now is always partly a result of what happened before, no matter how far back you trace it. Whether or not human life works exactly the same way mathematically, the question it leaves behind is worth keeping. What are you setting in motion right now that you're too close to see clearly? The butterfly never knows about the storm, but the storm always knows about the butterfly. Thanks for watching. Next time, why your brain is physically incapable of making a truly rational decision, no matter how hard you try.